Systems more separate in the United States than other places. In the case of cybernetics, the idea was to develop a theory of control and communication as opposed to a theory of matter and energy. Both of these fields grew up in the days after World War II. Now, the way I think of these fields is that we operate at three levels. At the level of philosophy, theory, and practice. And maybe all fields, scientific fields, do that, but I think we do it more explicitly than other fields, perhaps. And you will see this throughout this presentation. So most academic work tends to be limited both in terms of the area of interest and in terms of the methods used. And that's why I emphasize these three things: practice, theory, and philosophy. As a part of the effort to create these more general theories, systems and cybernetics have made contributions to a variety of fields. And I will illustrate this with three examples: the field of management, the field of social science, and the field of philosophy of science. So, contributions to management. So think of this as a kind of helicopter view over a quite varied landscape. I'm going to have to go fast because I don't want to take too much time. There are basically three models used in management: regulation, self-organization, and reflexivity. Regulation uses two basic elements: the regulator and the system being regulated. Self-organization uses many elements. Think of an ecosystem or an economy. Reflexivity consists of many elements that operate at two levels. You both observe and participate, and observe and participate. Regulation is essential in cybernetics. Homeostasis in the body is an example of many regulatory processes that control your blood volume, blood sugar level, etc. Similar multiple feedback loops exist within businesses and in societies. However, most of science emphasizes linear causality in the sense of independent variables and dependent variables. The reason we do that is because we want certainty. And the way you get certainty is by using statistics at a high level of statistical significance. But according to cybernetics, linear relationships is not where the action is. The action is in circular relationships, because circular relationships, whether they're positive or negative, indicate stability or instability. There are some variations of regulation. There's Ashby's theory of adaptive behavior. We saw that earlier in the conference. Ashby postulated two nested feedback loops. You have one feedback loop that does learning and a broader feedback loop that does adaptation. So you learn about an environment, and then you realize the environment has changed, and you have to learn again, and that's adaptation. The law of requisite variety is a fundamental law. One of the reasons I'm doing this is because this isn't known within the field of management. It's been around since the 1950s, but you won't hear any mention of this at meetings of the Academy of Management in the United States. The law of requisite variety states a quantitative relationship between regulation and the system being regulated, between information and decision-making. One would think this would be of interest. For reasons that I haven't mastered yet, it doesn't arouse the intrigue and the curiosity of people in the field of management. Now, in the case of regulation, if you want to increase your capability, there are two ways of doing it. You can either increase your capability by hiring staff, buying a computer, or something like that, or you can reduce the variety in what you're trying to control. That may not sound like a very strong strategy, but it's extremely powerful. Basically, it just means you don't pay attention to that much. You decide what you want to control, and you focus only on that. For example, let's say you want to regulate the global economy. You can adopt four strategies. One is a one-to-one regulation. You see that in games like soccer, basketball, and so forth. Or you can pass a law and says, then you only need to regulate illegal activities, not all activities. That gives you an amplification of your regulatory capability by about a factor of 1,000, if you count the number of policemen and the number of citizens in the community. A further amplification can be achieved if you let the elements in the system regulate themselves. For example, let Ford compete with General Motors, compete with Chrysler, and all you do is set the rules of the game. No agreements and restraint of trade, no price fixing, and no monopolies. If you count up the number of federal regulators in the Commerce Department, the Federal Trade Commission, count up the number of managers in the country, you get about 1 to 1,000,000. All right, so that's another amplification of approximately a factor of 1,000. Now let's say you want to regulate the whole world, you have to not only change the rules of the game, you have to change the game. That was done with the Club of Rome report on the limits to growth, where they said, don't worry so much about military competition and ideology, think about population and environment. It was a change in the game, and that was done by about a dozen people, and it affected about 6 million. So if you're trying to amplify management capability, you get a substantial amplification simply by changing your strategy, by choosing to look at something different. And note that it is possible to manage a social system composed of millions of people, even though human beings are limited in their conceptual capability by the magical number 7 plus or minus 2. This is something from psychology that says you can only pay attention to different things. Those of you who are engineers know that there's something called power amplification. Think of a stadium with loudspeakers. And also think of a auto repair shop where you take in your car, flip a little switch, and up goes the car. That's a significant amplification of the effort involved in flipping the switch. It's a significant amplification in the stadium of the song you're singing versus how many people can hear it. They're the same thing. It's the same underlying phenomenon. You're controlling a large flow with a small valve. Okay. Another example of regulation is Stafford Beer's viable system model. I assume almost everybody in the room knows what Stafford Beer's viable system model is, so I'm not going to go into it now, other than simply to point out that it also uses Ashby's conception of adaptive behavior, because you have, in the viable system model, you have 5 systems. 1, 2, and 3 are learning, and your basic process of learning, and systems 4 and 5 are adaptation. That's when you change what it is that you're doing. And also, each level in the viable system model performs these 5 functions. This is an enormous advantage in terms of trying to communicate with other people. Beer used this in Chile to help business people all across Chile communicate about the economy, and it worked very well. So that was regulation. Now, self-organization. Self-organization was developed in the 1950s, the concept, during discussions of how do you make a machine that seems to be intelligent. One approach is to tell the machine what to do, step by step. Do this, 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 and that's called GO-FI, good old-fashioned artificial intelligence. The other approach was learning. Create the capability in the machine so that as it interacts with an environment, in a sense, organizes itself. They went with GO-FI initially because they didn't know how to do the learning. Now they know how to do learning. It's called deep learning, and that's the way things are done. And actually, you combine the 2 approaches. So like I said, self-organization consists of many elements that go toward their stable equilibrial states. This is also a strategy in management. For example, an incentive system for salespeople. You say, sell this object rather than that object, and we'll give you a larger bonus. Okay, that's changing the rules of the game. If you can change the rules of the game, people will go in a particular direction. They adapt to their environment. So by changing the interaction rules, the elements of the system adjust their behavior. They're sending people toward a different equilibrium than they were going toward earlier. And also, self-organization is the idea underlying agent-based modeling, which is the idea underlying complexity theory. It's a new form of computer simulation. So, reflexivity is the 3rd basic model within management cybernetics. A reflexive system is, in a sense, a conscious system. You look around, you decide what's going on, you decide what your goal is. You decide on the course of action, you intervene in the system, step back, see what are the consequences of that, come up with a new course of action, implement that, look at the consequences, and so that's a reflexive system. So an example of a reflexive system in the field of management would be group decision-making processes. I assume most of you have participated in group decision-making processes. The task is to lead a group through a conversation with the result being a plan of action that they work on together. Various participatory methods have been created in order to do this, but action research tends to be thought of as lying outside normal social science. An example of group decision-making is that a facilitator leads a group of people through a process. For example, you could ask the first question, what do you want to see happening in your organization in the next 5 years? People write these things down on cards, put them up on the board, cluster them, talk about them, and then say, okay, if that's what you want, why don't you already have it? Write these down on the board, cluster them on cards, cluster them. Say, okay, if that's the set of obstacles, how are you going to remove the obstacles? What are some strategies? Write them down on the cards, put them on the board, discuss them, and say, okay, if those are your strategies, what tactics do you need to do to implement those? Write them down on the cards, etc. At the end of it, you have who's going to do what, when, where, and how in order to implement these plans. That's the way you do organizational learning. It works in businesses, government agencies, universities, NGOs. So you work on the plans that you made for 6 months to a year, and then you come back together, you look at the report you wrote, and say, well, what did we say we were going to do? What did we actually do? What was more difficult than we thought? What was easier than we thought? What additional resources do we need? And then you go through the whole thing again. What's your vision of the future, etc. That's management. Now, social science, another realm of activity. Most social science researchers use the approach borrowed from the physical sciences. The observer was outside the system of interest. The emphasis was on making objective observations. There was a search for quantitative measures, and statistics were used to find relationships between variables because you were looking for certainty. Problems with the social sciences. Well, the doctrine of the unity of method has distracted social sciences from noting the different types of basic elements in social systems. For example, in the physical sciences, variables take you a very long way. But not everybody in the social sciences uses variables. Some people look at ideas, groups, and events. For example, you can think of the process of social change like this. You start off with variables, you study your system, you say, how's it doing, get some measures. And you say, how can we improve it? So you come up with an idea. Well, that's not enough. You've got to get people to buy into the idea. So you have to form a group that shares that view. If you succeed in doing that, maybe you can produce an event like a piece of legislation or set up a new corporation or something like that. And then after you've got that thing going, you look at variables to measure it, study how it's doing, come up with a new idea. You have a process of social change. But notice, you've now used several different social science disciplines. Because variables are primarily the domain of economics, events are things like history and law, groups are sociology and political science, ideas include psychology, philosophy, cultural anthropology, and so forth. And so by using these 4 basic elements, you produce a more diverse, multifaceted set of descriptions of what's happening in the social system. So you have less chance of missing something important. Okay, so reflexivity theory provides a theory of what I've just been describing. Observers are included. Multiple perspectives arise naturally. Relative to the old social science research, the new social science research is more participative and more conceptually varied. So that's social science. I'm suggesting we've come up with ideas, we've developed methods that are useful in extending the old conceptions of social science. Now, philosophy of science. A goal of philosophy of science. Now, this isn't really my field. I get this indirectly. So if somebody wants to correct me, please do. The old philosophy of science was to teach scientists how to create justified true belief. Okay? In other words, they want ideas that are accurate, and they want to have justification, empirical justification, so on. The problem of induction was an obstacle. How many of you are familiar with the problem of induction? Not everyone. Okay, deduction is simple. If you got your axioms right, your logic right, any conclusion is true. Induction is a problem because you're going from empirical observations to a generalization. And that's tricky because you can see a lot of white swans and come to the conclusion all swans are white. As soon as you see a black swan, your proposition is invalidated. Okay, that's the problem of induction. So how do you deal with that? Well, you formulate null hypotheses and alternate hypotheses. You don't try to accumulate evidence for the alternate hypothesis. You try to reject the null hypothesis. This is kind of weird, but doctoral students have to get used to this. Also, you try to eliminate observer effects. However, if the scientist is excluded, who formulates the hypotheses, designs the experiments, and interprets the results? It's very difficult to eliminate the observer. So what is the foundation of scientific knowledge? Floating foundationalism is the term to describe what the philosophers have been concerned about. Because it used to be you could go back to physics. Right? Say, okay, we have atoms, molecules, then we have chemistry, and then we have biology. Somewhere along the line, you have trouble making the transitions. So how do you create certain knowledge? So what do? Do you just abandon the idea of philosophy of science?
Yes.
According to Carl Miller, that's what they've decided to do. They have, the Vienna Circle in Vienna, they still meet and so forth, and they say, just given up on it. But Warren McCulloch said, well, now let's think about this. Okay, where does science come from? Well, it's the product of the activity of the human brain. How does the brain work? Well, let's investigate it. So we'll do neurophysiological research, figure out how the brain works, and provide that as the foundation for our conception of science, which is what cybernetics is doing. But that means that science becomes not a normative endeavor to do this, and this, but rather becomes an experimental inquiry. And you have to include the observer in the activities of science. You emphasize the difference between inanimate objects and thinking participants, which wasn't really mentioned during the document of Unity of Many. You create a multidisciplinary theory of social change. You renew the emphasis on general theories because you want to have parsimonious theories. You want to explain a large range of phenomena with a small range of propositions. You provide a biological foundation for knowledge to critique, and you use science to critique philosophy rather than philosophy to critique science. And that leads you to greater interest in cross-disciplinary theories and the application of science. So, the foundation for philosophy is placed in neurobiology and mathematics, Russell's paradox, for example. You try to clarify what is achievable, not certainty, but an understanding of cognition. You provide an explanation of how to expand science using the correspondence principle, which comes from physics. I've written about this on paper. It's a way of incrementally expanding science. And you resume the practice of critiquing the progress of science, which had been set aside. Now, going back to the origin of cybernetics, Norbert Wiener said you have two industrial revolutions. The first was the use of knowledge to replace human muscle power. The second is the use of computers to replace human intellectual activity. What we've seen at this meeting, I think, is an increasing interest in processes like learning, adaptation, purposes, consensus, understanding, and narratives. And that's rather far outside the realm of matter and energy. So we're deeply into the second industrial revolution. So in conclusion, Systems and cybernetics contribute to the additional disciplines by creating more general theories, creating the science of control and communication in addition to matter and energy, by showing similarities among ideas in traditional disciplines, by integrating knowledge from many fields, by providing transdisciplinary language for the informational domain and for science itself, and by contributing to philosophy, theory, and practice. So I think we have done what we set out to do in the field of systems and cybernetics, at least as far as we've gotten so far. And I'm hoping we can persuade some funding agencies to give us some cash for the next step.
A question or two for Stuart. Robert.
So, Stuart, you might say something about how physics, which is sort of the ultimate science, is now running up against these same kinds of problems that social science has come up against, which is that the notion of objectivity is no longer, is less and, the notion of objectivity in physics is less and less viable.
Yes, no.
So you can talk a little bit about
they
that.
think it's their idea. You know, they think they invented the observer. So the physicists are on board.
Other questions, thoughts? Yeah, thoughts.
You're describing cybernetics as kind of the super discipline that solves all the problems. I think that is a hopeless enterprise. Physics is a very strong discipline. In physics, there are also people that are critics. Like, for example, Heisenberg saying that reality is the answer to our questions. So there you have the observer. But the point is actually, physics describes. The main thing of physics is, because what it describes, it cannot answer. You're free to do anything you like, but in the social sciences, it's different. And that's the reason why I think cybernetics ought to be a critical discipline, a discipline that should criticize others, whichever way they want to go. But I think there should be some notion, for example, of conversation, of caring for people, as opposed to systems. I think that's missing. I mean, you focus too much on big systems. I think we have to look at what the systems are made of. And that's what I think is missing.
Thank you.